over 1 minus 1. So I want to know the probability that exactly 2 of these 3 variables are less than 0. And I know x1, x2, x3 are mutually independent. Alright, to know the event A as exactly 2 of those 3 are less than 0. Okay, so you should know how to write the probability of this event. Exactly 2 of these 3 are less than 0, which means the other one is greater than 0. Greater than or equal to 0. Okay. So it is the probability that x1 greater than or equal to 0 and x2 smaller than 0 and x3 smaller than 0 plus probability that x1 smaller than 0, x2 greater than or equal to 0, x3 smaller than 0, and plus probability that x1 smaller than 0, x2 smaller than 0, 3 greater than 0. You know how to calculate these probabilities? They are independent. So these events are independent events. So I can write it as x1 greater than 1, greater than 0 times x2 less than 0. Plus x1 smaller than 0. So for this question, you just need to know independence, and you just need to know how to come up with the probability that x1 is smaller than 0, and x2 is smaller than 0, x3 is smaller than 0. So I don't want to write it down in detail, so you should know how to find this probability because they are all normal, so we can standardize it. And after you standardize it, you use the normal distribution table to find the probability. Yeah.
Do you mind writing that out? Because it would be a really good refresher on standardized it.
Okay. So the probability that x1 is smaller than 0, x1 is itself a standard normal. It's normal 0, 1. So this is just, x1 is the standard normal. So this is just phi 0. Okay, phi is the CDF of the standard normal. Okay, and phi 0 is 0.5. And for x2, smaller than 0, so x2 follows normal mean 2 and sigma squared equals to 4. So to standardize it, this is x2 minus mean divided by the standard deviation, which is 2. And it is smaller than 0 minus 2 over 2. So after you standardize it, it is a standard normal. It follows the standard normal distribution. Okay? So, and this right hand side is minus 1. Yeah.
Why is that different from the x1 is less than 0? Is it because since the mean is 0, you don't have to go through those steps? Is that what
No, because x1 is normal 0, 1, which is already a standard normal.
Oh, so 0, 1 is a standard normal in all cases?
Yeah.
Okay.
I mean, the definition of standard normal is normal 0, 1.
Okay.
Yeah. Mean 0, variance 1 is a standard normal. Okay. So this is phi minus 1. But in the distribution table, you cannot find phi minus 1. But you can find phi 1. And you should know that phi minus 1 is 1 minus phi 1. Okay. Okay, you should know that phi minus x is 1 minus phi x for any real number x. Okay. So you can also get this from the distribution table. And this probability is is 0.01587.
Really fast. You said over to the left we should know how to find the probabilities. Can you refresh my memory for like x1 greater than 0?
Yeah, because x1, x2, and x3 are mutually independent. And this means those events to be mutually independent events. And for mutually independent events, the probability of their intersection is just the product of their individual probability. So we can find all those things from this, and the probability that x3 is. That's the difference. X3 smaller than 0. There's 3 minus 1, which is plus 1, divided by 1. Smaller than 0 plus 1 divided by 1. And this is just 5, 1. And this is just 0.84, 13. Okay. And for px1 greater than or equal to 0 is just 1 minus px1 smaller than 0. Okay. So just stick those things in here and compute it to get answer.
But you said greater than or equal to 0 is just 1 minus.
1 minus smaller, the probability that x is smaller than 0. Okay.
So what's the answer?
The answer is, I will post the answer, I will post the solution later, but the answer is 0.433.